Welcome everyone. Today's lecture we will be learning about microcontrollers and more specifically focused on Arduino, what it is, and its features, the basic information relating to Arduino boards, and learning the basics of how to program the Arduino board using language syntax, using variables, how to perform the basic input output, or to perform analog to digital conversion. And so this will be very important lecture in our course, since it's the beginning lecture, and it's very important for everyone to pay attention to the details, ask question, take notes, okay, so that you can perform better in the lab time and also in the subsequent lectures and lab times. Okay, so let's carry on. So this particular slide, as you can see, the question is, what is a microcontroller? And this particular picture, what you see, gives you a very good kind of in a quick snap an answer to this question. So as you can see, this is a microcontroller chip. This is one of the chip, but this particular microcontroller chip, this is the block diagram about for this microcontroller chip. And in this block diagrams, all these ICs are there in this block diagram, which is part of the microcontroller. So in simple words, microcontroller is a highly integrated chipset. So it means that it contains many chips in a single IC package. So that's what a microcontroller is. And what are those integration key chipsets or functionalities or blocks? The most important one is what we call it as a microprocessor, that is the CPU, or called as central processing unit, for the microcontroller, the brain of the microcontroller, for which we write the program, and the CPU executes those instructions. The second most important part of a microcontroller is the RAM, or the program memory. Okay, and most of the time, it's a flash memory, or a different type of a memory on the microcontroller chip. As you can see here, you have a RAM here, we have a program memory here. So here's where the program resides, and here's the additional memory for storing runtime variables or data relating to how the program is written. Then we have the other important functionality within a microcontroller. In this case, Arduino is analog to digital converter, and it basically brings in analog world information like temperature, pressure, or any other sensing information, and converts into a digital number or digital value, which you can bring into your program, and we will learn that how you can use that information to fulfill a particular requirement. And there is an on-chip oscillator which goes from 0 to 40 megahertz. Depending on, it can be a different value, but an on-chip oscillator is one of the important element within a microcontroller, and because that is the heartbeat of the CPU, which keeps it running. So that is also part of the microcontroller. So again, what is a microcontroller? It's a highly integrated chip which contains many functionalities. In simple words, a small computer on a single chip contains a processor, memory, and input output. So it's a small computer on a single chip, contains processor, memory, and I/O, typically embedded inside some device that they control. A microcontroller is often small and extremely low cost. And if you click on this link, you will find some additional examples relating to the examples of what is a microcontroller. Okay, but since we are focusing on Arduino in this particular lecture, so let's focus on this for now. So another important question is that what is a development board? A development board is a PCB. So as you can see, this is the Arduino board. So all the components populated on this particular board, we call it as PCB, and PCB stands for the term printed circuit boards. And so the Arduino board designed as a development board to facilitate working with a particular microcontroller. So the obvious question is, so Arduino board uses what type of a microcontroller from which vendor or IC manufacturer? So Arduino Uno R3 series uses Atmel Atmega 328, which we'll see in the subsequent slide. So but any board which is designed around a microcontroller, a microprocessor, or a DSP or an FPGA is called a development board. So that is important to understand. And the typical components include on a PCB is basically it has a power circuit, that how we're going to bring in the power onto the PCB and power up the respective components or power up our circuitry or design. It has a programming interface, and for Arduino it's a USB cable we will use in our lab time to connect the Arduino with the PC or laptop and be able to program the Arduino Atmega microcontroller. And to perform the basic input, usually buttons and output using LEDs. And again, so it provides additional I/O pins, which we will learn in the subsequent slide, for additional functionalities, features, and objectives relating to a certain design. So this is what an Arduino board is. This is called Arduino development board, and this is the microcontroller chip, the main part of this development board. And this is from Atmel Atmega. It's a 328 part number of this Atmega series. The important another important point for all students to know that this IC package is called DIP. DIP stands for dual inline package. Why? As you can see, it's line number 1, line number 2. So it's dual inline. So as you can see, they're both inline. So dual inline package, and also called a DIP, and it's a through hole IC used for any IC of DIP or PDIP. Most commonly you will see there is on the top left, there either is going to be a dot on one side or there is a notch in the center, and that information is there to tell you where is pin number 1. So in this particular case, the pin number 1 for this microcontroller is right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The 15th pin is here, and all the way to pin 28. So that is a very important information relating to not only DIP ICs, but also, this is SOIC. Again, it is very common to dual inline packages. Okay, so that is the microcontroller. The other important, this is the USB connector, and this is what we use to program the microcontroller. There is another way we can program the board is basically this is called in-circuit serial programming header. If you have that particular adapter, you can also use this to program the microcontroller. Uh, so to power up the board, we will use the USB, and that can power up the board. We don't need any external additional power supply. But if let's say you want to use your project in a box, if you're designing a box for any kind of a environment, so in that case then let's say you don't want to use USB cable to power up, then you can use your this DC jack, and you can connect the DC power supply to power up the board. Or even if you don't want to use this, there are external the way you can connect to power up your Arduino board. Okay, so multiple ways to power up the Arduino board. As you can see, this is a 16 megahertz crystal here. This is kind of the hard clock for the CPU, and this is the USB to serial IC. So this particular IC, what it does when you connect USB cable here, so it because of this IC, you will see a COM port on your device manager or device list, or inside Arduino IDE, you will see this as a COM port. Okay, so these are this is your D13 LED. This is an LED, we call it as the internal LED, kind of for numerous projects. This is the serial transmit receive LEDs. These are the ones, and this is to indicate this LED to indicate when the if the power is reaching Arduino board. So whenever you plug in USB, DC jack, or any other way, this LED turn on means that the Arduino is powered up. This is the reset switch, and these are the digital I/O pins. And we will use it for in our lab time for different projects. You can use it. We will learn how to use these pins. These are your analog I/O pins. So this is this is wrong. Not an I/O. This is only for the inputs. You cannot do an output on an Arduino because I think it doesn't have a DAC. Yes, as long as I recall, it does not have a DAC. So these are all input analog channel. So applying within the range voltages at these inputs and programming it appropriately in your Arduino program, you'll be able to read the equivalent digital values for the respective analog input channel. Okay, so again, this is very important to understand that how the board looks, what are its critical important components, and the location of those components, and having that information will really help you complete your lab and associated projects. Okay, so let's carry on. So this is the Arduino microcontroller from Atmel, Atmega 328, and this is its kind of the pinout. So this is, as I said, it's a DIP package, a PDIP for pin package, which is kind of a through-hole IC. Okay, so we are not going to discuss the entire details, but all these pins are the relevant important pins are available on the ports, like the digital I/O and analog I/O. So they are routed onto the Arduino board port connectors, so that you can easily connect or perform input output digital for operations or for analog input operations. So this is a kind of a high level block diagram of this Atmega 328 chip. It has a CPU, which is basically the processor. It has a flash, the RAM, different type of memories. It has the timers and counters circuitry on it, analog comparator, analog to digital converter. Analog comparator is basically kind of an op amp. You can use it for numerous purposes. It has interrupt block and the serial UART within it. So as we will do more labs and projects using Arduino, you will be more clear on how to use these blocks, and you'll be more familiar as we use to implement certain design requirements. Again, an Arduino, the board, and this is the development environment, just showing you as a snapshot. In the lab time you're going to learn more about it. And Arduino has its own community and philosophy, and a very popular board since it's low cost, easy to use, and easy to program, and easy to achieve simple basic projects using a microcontroller, so easy to learn. Okay, let's keep going. So please click on this link to check its homepage, and from here you can also download and install the IDE. IDE stands for Integrated Development Environment. It's basically, that's what the IDE is. Once it's successfully installed, you will see this IDE, and then you connect the board using a USB cable. Once you will connect it, you will see it COM port in the device manager or within the IDE, and that's how you will connect it. We will learn how you will do that. Sometimes it's required to install the drivers, but if your computer operating system is most up to date, most likely it will be very smooth kind of install of an IDE. Then you launch the IDE, and then you select your board, you select your COM port, and you open up the blink LED example, upload the program to see the demo. Okay, so let's keep going. So here's in the laptop, what are you going to do? Bring in your Arduino, okay, and we're going to do this basic operation of blinking the internal LED. So you will connect your USB cable on this connector. You make sure that you will see this power LED turning on, okay, and then you open up the IDE, and in the IDE you write this code. So you write this code. I prefer to write it, or you can just simply go to the sketches, because the Arduino programs are also called sketches. So you click on the sketches, and from within there you will see the blink LED project. So here the blink LEDs project is already open, but I prefer that you write the code yourself so that you feel very comfortable. So let's understand the code here. So in this program there are two functions. This is the setup function, okay, and the other is the loop function. So the setup function, where in Arduino environment, only run once, okay, at the start of the program. So let's say when you download the program will enter this setup function and execute all the commands within that setup function. But again, it's only going to happen once. So in this program, so what it's going to do, because this is the command line, this is a single line command, like a C++ style, and again this is the block command. So from slash and asterisk slash, this is the block commenting, what we call it as. So that's why these lines are just commands. The compiler is not going to, or in Arduino case, interpreter is not going to worry about interpreting or compiling these lines or these lines. So the first line will be this pin mode. So pin mode is basically an Arduino function, which basically what it's doing, it's saying that I want pin 13 to become an output. Okay, so where is pin 13? If we go back and you see that this is pin 13. Okay, so this pin 13 we are making it as an output. Okay, but if you don't want pin 13, so you will use internal LED. There is a project in the sketch. Within there you will open, and you want to, let's say you just simply want to blink this internal LED. So there is you just need to type internal LED or onboard LED, and the variable is already defined. You will see in that example sketch what it is, and you just simply make it as an output. But in this example it's trying to make pin 13, which is available on the connector, and making it as an output. So it means you have to connect an LED with the resistor at the output in order to see the functionality. Okay, so once this command is set, so as I said, that this makes the pin 13 as an output pin. But the other important thing to understand, that this is just a simple function call, but underline what this function is doing, it's going inside the microcontroller register, okay, and setting up the respective register port bit, the respective bit which is for port 13 as an output. So it basically primarily what it's doing, it's making that particular bit as 1 or 0. Most commonly 0 means it's an output, 1 means it's an input. So this statement is setting up the registers for Arduino board. So a very important point to understand and be very, very clear on. Okay, that's how easy it is to set up registers if you're using Arduino. In some other cases that's not that simple. You have to know the address, you have to use the right function, and you have to put the right value in there as well in order to set up and achieve kind of a similar objective for a respective microcontroller. But Arduino, and the reason behind its popularity is because it's very easy to make a pin as input or output. Okay, so then after this, because in this setup function there is only one line, so once this line is executed, the setup function is done, and then it basically enters, the program enters into the loop function, and the first line in the loop function is that it's writing to port of the pin 13 the value high. So it means it's writing 1 at that port, which is basically intended to make the LED go on. Okay, and then there's a delay of 1000 millisecond. 1000 milliseconds means 1 second, and it's writing again on the same pin and to making it low means it's making it 0, and again a delay. So it means that these 4 lines will keep on running forever, as long as you want. And again, high, low means it's just simply going to blink an LED and every second, and you will see it if the proper connections are made for that circuit at the pin 13 port. Okay, it's nothing. So you can connect. You will see. Yeah. So this is basically. Let's say once you have written the program, you will just basically go and select your port. If you have one, you will only see one. If you have multiple, make sure that you identify by plugging in and out the USB cable of the Arduino to see that which port is popping up here, and that is a port number assigned for that Arduino board. Select that port, and then you select your board, which is Arduino Uno. Okay, and then you just basically upload your work. If there are some errors, you will see it, and you need to correct your errors before you can run your program. But if everything is set up, then it should be pretty straightforward thing. So again, you have your sketch, you basically compile it, and you upload it to the board, and you will see your in this case it's showing you that the sketch is running and blinking the internal onboard LED. Okay, but for the example which we discussed, as you can see here, pin 13, the anode is connected to pin 13 because of this edge. This is an anode, and this is the cathode side is connected to the ground. Let me go back to, if you see here, this see, this is the ground pin, okay, and this is pin 13. Okay, so it's what it's doing, it's connecting the cathode side, which is this side, to the ground and the anode. And why I can see that, because of this, the notch here, the edge here, this is the anode side, or the longer leg is the anode side of the LED, and that is gonna connecting with pin 13. But I highly discourage making a connection like this, because it can damage your LED easily. So this is not a good kind of a snap. I prefer to have on the anode side or on the cathode side a resistor of 100 ohm or 200 ohms or 300 ohms, just to limit the amount of current flowing through the LED. Okay, so and this is the schematic symbol of an LED. An LED has an anode. Wherever you see a plus sign, that means it's an anode side. When you see the negative side, it's the cathode side. Or if you see the legs as the longer leg, this is the anode, a shorter leg is the cathode, and here's the schematic symbol for the LED. This triangle is the anode, this line is the cathode, plus and minus, and these arrows means this is an LED which glows light out when the proper voltages are applied. The forward biasing voltages. Forward biasing voltages mean that you get a plus on this side, and with respect to the negative, it's more plus. That's how the current flows. And when the current is flowing through the LED, is going to give out light. But if it's a reverse bias means the plus side is connected to the negative voltage, and the negative side is connected to the positive voltage. In that case, it's not going to glow up light. Or if the voltage in here is near to ground, it's not going to glow up. Okay, so I think it's basic, and any questions, concern you have in your minds, please do ask. Okay, so let's carry on. So this is a bit more about programming. As I told you before, the Arduino program is also called a sketch, and the code is case sensitive. Case sensitive means whenever you write the command, any command, the lower letters in the command or the capital letters do matter. That it means by case sensitive. So for example, in this example here, you write the pin. You see the pin is lowercase, M is uppercase, ODE is lowercase. You cannot just simply make it all uppercase or a combination of any upper or lowercase. No, it has to be written like this. That's what it means by case sensitive language, or a programming language uses case sensitive. And statements are commands and must be end with the semicolon. So every statement ends with a semicolon, as you can see here, or in the previous example, as you can see here, every statement ends with a semicolon, which is same like as C or C++. And we already learned about how to comment a single line, which is 2 forward slashes, Or to comment a block of lines, you can use /* to start the comments, and to end it an asterisk and a /. Okay. And again, the same example, which would be more clear on it in this particular snapshot. And what are the relevant terminologies? An Arduino program is called a sketch. A pin is basically can be set up. You can set it up a pin as an input or output. Digital, value is either high or low. Also called as on and off, or 1 or 0, or kind of a switch state to make the switch on and off. And analog values ranged usually from 0 to 255, but Arduino board is a 12-bit ADC, and its values goes from up to 2 to the power 10 minus 1. And we already, if you aren't sure about what I mean by 2 to the power 10 minus 1, please raise your hand and ask question, and I'll explain that. And these LED brightness, motor speed, and etc. That's relating some of the example applications on where we can use the analog functionality to control the brightness of an LED, or speed of the motor. Again, a bit more detail about the digital IOs. We already used the spin mode, specified the pin and the mode, whether it's going to be input or output. In our previous example, we made it as an output pin, and we can use this digital read function and specify the pin number to read the value as 1 or 0, low or high, from that pin. And we can write the pin, if it's an output pin, specify the pin number and the value to it, to make it high or low. And very important information, that the output pins can only provide up to 40 milliamps of current. So it means if you put a load that's why I was saying, connecting the LED directly, it's can potentially even damage the microcontroller pin as well, or the microcontroller or the board itself. That's a good idea. Make sure that you limit the amount of current drawn from the microcontrollers, but typically it's in few milliamps only. Okay, here it's 40 milliamps. So another important point is, when you write a high to the input to an input pin, it basically it installs a 20 kilo ohm pull-up resistor. When you read a high, as we go along, we will learn about it, what this or similar statements mean in relating to using Arduino or any other microcontroller board. Okay, so let's carry on. So relating to the timing, as you know, we have used the delay function. So when we specified in our previous example delay 1000, so 1000 number means it was 1000 millisecond, and 1000 millisecond means 1 second. You can also use this delay microseconds function and specify the delay in microseconds, and more commands by just clicking on the link there, and go and see what other commands are available for Arduino programming. Okay, so this is basically kind of a very introductory slide on what is a digital thing and what is analog. So digital term means that the values are only on and off. Okay, so the voltages are either, like for example, if you see my mouse, let's say this is my voltage level 0, ground level. If this is my voltage level 0, so the 1 will be high here. Okay, so this is my voltage level 1. So digital only has two values, 0 voltage level and 1 voltage level. When I'm saying voltage level 1, it means that voltage level can be 5 volts, 3.3 volts, 1.8 volts, 2.7 volts. With respect to the zero voltage, which very commonly is only close to ground, but not always necessarily that zero voltage can be a negative voltage. So, for example, my zero voltage is negative 5 and my plus voltage is plus 5. But the important thing is digital means it has only two levels or two values, on and off. And that on means on can be voltage level of 5, 3.3, 2.7, 1.8 or any other value. And off, most commonly it's 0 volts. Okay, so just remember this. The digital means only two states, 0 and 1. Analog has many states, basically theoretically, mathematically, infinite number of values. So if you see, the world is analog, and that's very, as you see, this is a signal, just an arbitrary signal, this solid line, and this solid line is, very continuous. So we cannot say by any means that this is an it has some discrete or digital levels. It's very continuous. That's how the nature is. Like temperature, pressure. These are all analog parameters. But to digitize it, we use analog to digital converters, and that's what we do. These dots, what you see here, that's we are sampling it. We are sampling at these points and holding it till this point. That's called quantization. So we sample and hold. Again we sample and hold. Again we sample and hold. And that's how we convert an analog information or analog signal and convert into the respective digital signal or digital value by using analog to digital converter. Okay. Computers don't really do analog, they quantize, and that's exactly what I mentioned. Remember the 6 analog input pins. Here's how they work, and that's, you apply the signal at the respective analog input pin within the limits of the voltage levels, and you enable your ADC and read the values just like this. So that is relating to, again, the digital information. So as we already learned, the digital means it only has two states, as you can see here. It's a bit. Okay, so here it can be 1 or 0, but we are trying to understand the relevant terms relating to the digital information, bits and bytes. So this location is only 1 bit, okay, and so the value inside the bit can be 1 or 0. This is also called least significant bit. Okay, another bit, another bit, another bit. So 4 bits together makes a nibble. So a nibble has 4 bits. So 1 nibble, second nibble, third nibble, fourth nibble. Okay, 1 byte has 2 nibbles, so 8 bits in a byte. 8 bits in a byte. 1 byte, 1 byte. Okay, and a word is 2 bytes. So that's what the technical terminology is relating to bits and bytes. On the rightmost side, on this particular slide, this is the least significant bit. This is what we call it as LSB, and the most significant bit will be on the leftmost side. Okay, so make sure that you understand this. Any questions you have in mind, please raise your hand, ask questions, or you can also ask during office or lab time. And that's how we basically convert between decimal to binary or vice versa. The least significant bit is basically 2 to the power, has a weight of 2 to the power 0. The next one is 2 to the power 1, 2 to the power 2, 3, 4, 5, 6, 7, as you can see here. And this information is very relevant to relating to how to convert decimal numbers into binary and vice versa, and we will learn about it if we haven't already learned. Okay. So this is just as an example that this is how a RAM kind of a module looks like inside your computers or inside different electronic devices. And this is showing you the CPU. In our case, it's within a microcontroller Arduino, and it basically connects externally with an address bus, provided that our design is like this. But in our case, both of these units are within our Atmega microcontroller. But there are, like on your desktop computers, that's not the case. You have just one CPU, and your external memories or external devices like motherboard, and the CPU communicates with those external devices in order to successfully run the operating system environment. Okay. So this slide is relating to the variables that we used or which we are going to use in Arduino sketches. An int variable type stores only integers, so this is an example that int num, and the value is 1. Int sum, again the value of this, stored only integer. An integer in Arduino environment is a 2-byte. I think it's a 2-byte memory location, but I can confirm as I during the lecture. Okay, but int means it's 2 bytes, but depending on the compiler, it can be 4 bytes as well. Double means it's used to store floating point numbers. As you can see, this is the digital or decimal number with the decimal in there. And most of the time, depending on the compiler, the double can be 4 byte or very commonly 8 byte long. Okay, so again, the int, depending on the microcontroller or the environment, can be 2 bytes or 4 bytes, and the double can be 4 or 8 bytes depending on the microcontroller and the development tools of the microprocessor you're using. This is how to store a string. Okay, so these are some of the basic data types in Arduino, and that's basically that how you're going to connect the example the sketch which we just did previously. The pin 13, you will connect a resistor and then an LED to the ground in order to glow up, and the LED safely. In this way, is going to limit the amount of current drawn from the microcontroller pin. Okay, and this is this example is relating to if you simply need to blink the onboard LED. So LED pin making high, low, and with a delay of 500 milliseconds. Okay. So please go ahead and in your lab time also practice this, ask questions to make sure that you are very clear on what we just discussed, so that you can perform better in your ongoing labs and projects. So here, what you see here is that in this case, you can rather than connecting like this, you can also make a connection like this. That this is, let's say, this is pin 13, current limiting resistor. Because this pin can be low or high, right? So you can connect the LED in a reverse way, okay, and have the anode side connected with the plus 5 voltage. So again, whenever it's going to be 0, the current will flow and it will glow up. Whenever it will be 1, the potential difference is not there, the LED will be off. In this case, whenever there is 1, because there is a high voltage and high potential difference, the current will flow. Whenever it's going to be 0, so there's no potential difference and the LED won't glow up. So this is again just to show you different ways that how you can connect your LEDs to make it blink. So these are the references relating to the slides and the lecture that we just did. Okay, thank you very much and see you next time. Take care.